Welcome back to Java Internals Crashcasts. I'm your host Sheila, and today we're diving into the fascinating world of concurrent collections. We're currently in our third season, exploring the deques chapter, and today's topic is the BlockingDeque interface. Joining me as always is our Java expert, Victor. Hey Victor, are you ready to unblock some knowledge for our listeners?
Hey Sheila. Absolutely, I'm all geared up to dive into the BlockingDeque interface. It's a topic that's sure to expand our listeners' understanding of concurrent collections.
Great. Before we jump in, let's test our listeners' knowledge with a quick quiz question. Here it is. In a multi-threaded application, you need to implement a work-stealing algorithm where tasks can be efficiently distributed among multiple processors, and tasks can be added and removed from both ends of a queue by different threads. Which Java interface would be most suitable for this scenario?
Oh, that's an intriguing question, Sheila. It really makes you think about the characteristics of different queue-like structures in Java. Work-stealing algorithms are fascinating and quite important in parallel processing. I'm sure our listeners will find this relevant to real-world scenarios they might encounter.
Absolutely, Victor. Now, before we delve into the BlockingDeque interface, could you briefly explain what a deque is for our listeners who might need a refresher?
Certainly. A deque, short for double-ended queue, is a data structure that allows elements to be added or removed from either end. Think of it like a queue where you can cut in line at either the front or the back. In Java, we have the deque interface, which extends queue, providing methods for both stack and queue operations.
That's a great explanation, Victor. So, how does the BlockingDeque interface build upon this concept?
Well, Sheila, the BlockingDeque interface extends both deque and blocking queue. It combines the double-ended functionality of a deque with the blocking operations we discussed in our previous episode on blocking queue. This means it provides blocking operations for inserting, removing, and examining elements at both ends of the deque.
Interesting. So it's like a two-way street where traffic can be controlled at both ends. Can you elaborate on what these blocking operations mean in practice?
Great analogy, Sheila. Let me expand on that. Imagine a two-way buffet line where people can join or leave from either end. Now let's say there's a maximum capacity for this buffet line. The blocking operations ensure that when the line is full, anyone trying to join will wait until there's space. Similarly, if the line is empty and someone tries to leave, or in our case, remove an element, they'll wait until there's something to take.
That makes sense. So what specific methods does BlockingDeque provide to handle these operations?
BlockingDeque provides quite a few methods, but let's focus on some key ones. For adding elements, we have put first and put last, which will wait if necessary for space to become available. For removing elements, we have take first and take last, which will wait if the deque is empty. These methods throw interrupted exception if the waiting thread is interrupted.
Those sound useful, but what if we don't want our thread to wait indefinitely?
Great question. BlockingDeque also provides timed versions of these operations. For example, offer first tries to add an element at the front of the deque, waiting up to a specified time if necessary for space to become available. Similarly, poll first retrieves and removes the first element, waiting up to a specified time if necessary for an element to become available.
I see. So it gives developers more control over how long their threads will wait. Are there any common pitfalls or best practices when using BlockingDeque that our listeners should be aware of?
Absolutely, Sheila. One common pitfall is assuming that because BlockingDeque is thread-safe, you don't need to worry about concurrency issues. While it handles the synchronization of individual method calls, you still need to be careful about compound operations. For example, checking if the deque is empty and then removing an element is not atomic.
That's a great point, Victor. How would you recommend handling such compound operations safely?
The best practice here is to use the atomic operations provided by the interface. Instead of checking is empty and then calling poll first, you should just call poll first. If the deque is empty, it will return null. This way, you avoid any race conditions between checking and acting.
That makes a lot of sense. Now, I'm curious, How does BlockingDeque compare to BlockingDeque in terms of performance?
That's an excellent question, Sheila. In general, BlockingDeque implementations might have slightly more overhead than their BlockingDeque counterparts due to the additional functionality they provide. However, the difference is usually negligible in most use cases. The choice between BlockingDeque and BlockingDeque should primarily be based on whether you need double-ended operations, not performance concerns.
Thank you, Victor. That's really helpful. Now, before we wrap up, let's reveal the answer to our quiz question. Victor, would you like to do the honors?
Certainly, the most suitable Java interface for implementing a work-stealing algorithm where tasks can be added and removed from both ends of a queue by different threads is indeed the BlockingDeque interface. It provides the double-ended operations needed for work stealing, along with the blocking and thread-safe behavior necessary for multi-threaded applications.
Excellent. To summarize today's episode, we've learned about the BlockingDeque interface, which combines the functionality of a double-ended queue with blocking operations. We've covered its key methods, discussed best practices, and compared it to BlockingDeque. Remember, while BlockingDeque provides thread safety for individual operations, care must still be taken with compound operations.
That's a great summary, Sheila. I'd just like to add that in our next episode, we'll be diving into a concrete implementation of BlockingDeque, the linked BlockingDeque class. It's going to be an exciting exploration of how these concepts are put into practice.
Thanks, Victor. And thank you to all our listeners for tuning in. If you've enjoyed this episode, please don't forget to subscribe to Java Internals Crashcasts and leave us a rating. Your support helps us continue bringing you in-depth explorations of Java's inner workings. Until next time, keep coding and stay curious.